Well, howdy, physics sleuths and inquisitive souls, and welcome again to yet another lecture of dynamic gravity. So, today we are going to cover fusion. All the different types of fusion, pretty much. And come out with whether or not any of them have any chance at all to succeed in their endeavors. Certainly like they claim they do. So, that's what we're going to do. This is kind of important because if we could master fusion for our species, then you'd have to admit it would pretty much change the world in the most radical way, and that now we would have cheap, clean energy for the world, theoretically. Of course, as always, the devil's in the details. So, unfortunately, when you crunch the numbers, some things don't add up. Some are, though. Some do, but a lot don't. But let's dig into that, shall we? Because it's an important one. I think so. It's been a subject I've been interested in is in fusion for decades now. And, of course, I think a lot of people have, and it's always been, everyone's been on the hook for, a long time with that whole thing they always say, oh, we're 20 years away from fusion technology working. It never works. It always, 20 years comes and goes, and nothing comes, of value comes out of it at all, in the slightest. But shall we begin? So, fusion. What do we got here? Okay, we've got nuclear fusion and cold fusion. Okay, there's a lot of different types of fusion. Low energy reaction, fusion, blah blah blah. These are from other things. Let's try this. Discovery. No, it's not so much it. There we go. Nuclear fusion. We'll start here. So fusion is obviously, take two atoms, combine together. Energy is released because once you overcome the force it takes to squeeze them together to bind, in the fusion process, there's a lot of energy as it stabilizes. It's released off. So, it takes a lot of energy to create it, but once you do, you get more energy out than you created, depending on, of course, the element. Once you get to iron and higher, I believe the fusion requirements are negative energy. So you get energy sucked out, which is the reason why theoretically they say stars can't fuse anything beyond iron, because at that point it's a negative energy loss and the star collapses and implodes on itself and explodes. So they say. Sounds plausible to me, but I don't really trust anything they say these days anymore. So of course they want to fuse hydrogen, together, because that's like some of the most energy you can get out. And they do it by having magnetic confinement, different processes, blah 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 blah. Fuse to get energy out. Okay. Stars, probably goes up to iron. It's gonna say, CNO dominates stars, heavier than the sun. Carbon, nitrogen, oxygen. So, different approaches. We got the fusion. Okay, there's a few. There's more than a few, actually. I think this one is meant to be like a star inside of a star. How it naturally does. This one looks like a stellarator. No, this is a not a stellarator. The other fusion thing. I can't remember the name of it right now. But yeah, the fusion big magnetic circular thing, and then the Stellarator is the one. This one I think was designed by a computer to be perfectly to maximize everything, but it's all like funky angles of the magnets, makes it harder to confine the plasma and everything. So that's that deal. And then you got this one here where I think you have like the lasers, all the lasers that hit like a thing that has something I want to fuse inside of it. All the lasers converge, and the pressure from the lasers and the heat supposedly make enough to fuse. The problem with all of these three anyways is that they really kind of suck. Like the Stellarator and the other Torrid, whatever the hell it is, I forgot the name. They're huge projects that are billions of dollars, and nothing ever comes out of them, like ever. I think right now, like they're bragging and they say they want even more, funding because they've been able to confine plasma for like, I don't know, 30 seconds or something stupid like that, and it's just like, you guys aren't even close, man. Like, you're not even close, dude. You're not even close. Just stop. The lasers, they claim they've gotten more power out than they put in, but that's not really true, because it's actually like, I think the largest laser in the world is what's powering this, and it's 192 lasers that all beam into like one spot. And so you got 192 lasers to fuse this little tiny thing, and I think the way they did the math, they don't count all the power that went into the power of the lasers and everything. They only count the power that actually hit the cube, to make the fusion. And if they do that, then yeah, I guess technically they have a net gain. But if you look at the actual electric bill on how much electricity they used to create that gain, it's pitiful. It's like a 1% gain. It's minuscule. It's really, really bad. So I don't believe this approach is going to work either. It just, this one I think they've been working on maybe like 20 years or so. But the Stellarators, they've been working on it for like 40 years now, and there's nothing going on there. They're just unable to get anything to happen. So the lasers, it's a dead end on that, I think. They do have another one too. They take a gun, like just a bullet, and just like try and impact and create fusion that way. Once again, I think maybe they'll be able to get some fusion, maybe, but the time it's going to take to reload and everything, and how much energy minuscule they're going to get out of it, it's just not going to, I think, ever going to be commercial needs. I don't think it's ever going to work on any level that's decent for anything. If anything, it's just a experimental thing to test stuff. Here he's kind of a Stellarator, homemade Stellarator, of course, not a professionally made one. But you can see how these are just magnets, and they're just tightening the plasma in here to go around however they want the core to be. Zoop, 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 like that. It's pretty cool. But the goal is they want to try and have the magnets so powerful and so much plasma that they're able to compress it to where it compresses it so much that they creates fusion. But like I said, I think it's a false stone. I don't think it's gonna work ever. I just don't think we have magnets that are powerful enough to do that sort of a thing. I just think it's a dead end. There is one fusion approach I really want to talk about, though. It's Helion's approach, right? I think these guys are located in Washington. I was tempted to apply and try and get a job working for them when I lived there, but ultimately I decided not to and to move away. But of all the approaches right now that are commercially going on to create fusion, I think these guys probably have the best shot of it. And what they do is pretty interesting. Here's a little roadmap you can see. They claim in their latest version, 2021, which is 5 years ago now, that they achieved 100 million degrees. Yeah, they're just trying. I think they're trying to get funding, to be honest. I don't think they're doing the numbers they claim they're doing. There's been a lot of people complaining that they aren't even going to be able to have any sort of funding at all. In fact, yeah, criticism, yeah, tired Princeton Plasma Fix Laboratory, blah, blah, blah. Allegedly practicing voodoo fission right there. So there's a lot of people that are betting against these guys being able to do anything with what they're trying to accomplish. But if they were to succeed, and I think they got the best chance of it, they would probably be set up the most. I think the fuel they want to use, or they think they can use, is more readily abundant than the one that the Stellarators use, which has to be made from nuclear reactors, pretty much. But yeah. So here's Helion's approach, right? They create two plasma donuts, two plasma rings, whatever, one on each side, and then they use magnets to accelerate them into each other and collide. And I mean, this is actually genius for a lot of ways, because number one, like the Stellarators are trying to, like I said, they're trying to squeeze the plasma together to create fusion. But if you notice, this is like an open loop, right? So if you squeeze harder here, a lot of the plasma just gets pushed out here. It's not like you're actually squeezing all the plasma that's there. It's more like a pressure thing where you squeeze here and then it just shoots out. Kind of like you squeeze too much liquid, incompressible liquid, it squeezes out. Yeah, this is a huge problem going on with a lot of this stuff that Helion does not have to worry about, because these are two plasma, circles, whatever, donuts are going to be colliding at each other very, very fast, like as fast as they can get them to go. Which, if they could get this longer, so they could get even more acceleration and more speed, and maybe have more of these, like 4 of these wings at least, all converging on the same point. Maybe even 6, man. Go all in. Every single angle. That way the plasma has no angle to escape from, and it only can be compressed by how much energy you put into it. That that might actually work, man. I mean, that I would love to see them try that approach as compared to this approach, which is flawed, and the cheap starter version, I guess, what they're trying just to prove a concept. But I don't think they're going to prove anything with this design. It's just too flawed. But I think they got the best chance. Because if you look, right, like here's basically what they're doing, right? They're creating plasmas. Now this is not from them, this is something else, but just to give you an idea of what's going on, right? There's your little plasma donut, just being shot out at insanely fast speed, right? It's being created and then shot out, and they're just colliding with each other. So if you get it at the right angle to where all of that energy that you have, velocity, is being crunched and being used to create pressure to squeeze the plasma to the smallest volume possible, I think it might actually work. Like, it really could work. I really believe it's possible. Definitely way more possible than any Stellarator or any other, like the laser technique or anything like that, the gun approach. And yeah, I think they got a good chance. And we know this definitely is one way to do fusion, right? We know this for a fact, because this is what happens in particle accelerators, right? They're taking like electrons, whatever, protons, anything, and slamming them into each other, going fast, and that collision of all the pressure and energy it's created is what's causing atoms to fuse together and to rip apart and to recombine and to create all new different things. So if they could, but then again, these are also going near the speed of light, right? Like 99% the speed of light to get that sort of a thing. So if I think we can definitely take away that if this Helion fusion apparatus was much larger in scale, something comparable to like a particle accelerator, right? Maybe not a full one, especially if they take my advice and they do from all 6 angles to compress it so it has nowhere to go, right? So it's all just eating that energy. Yeah, man. This is what particle accelerators do. So if you can make this behave as much like a particle accelerator, you're 100% going to get closer and closer to actually having fusion occurring in all sorts of crazy events because you're creating a particle accelerator with plasma particles instead of subatomic like protons and electrons. So that definitely would be the way to go. But of course, like I said, this is way too small. These plasma donuts are not going fast enough. You got to get some serious speed. I would say if they wanted to get serious, they're going to have to increase the size of this thing by like 100 times, and then make it 6 angles. And that, if they do that, they will actually, I believe, approaching fusion. I think they'll definitely be getting some fusion going on. And then it'll just be a matter of, is it enough, and can they siphon out the energy like they want, like having the magnetic fields expanded and how the magnetic field changes, they use that change to siphon out electricity. I mean, if they can make it work, that's pretty ingenious, I gotta admit. And then they can also do a lot of cycles with this pretty quickly too, because it doesn't take long to put a puff of gas in here, plasma it, and shoot it into the center. We're talking like a second, So you can get a lot of pulses, creating a lot of fusion events relatively quickly. You get a lot of energy out of there if you really wanted to, all right? So of all the commercial approaches to fusion, this is the only one that I believe has any chance of succeeding. And for them to succeed, they got to get serious with it. They got to quit messing around with these little tabletop things. I guess they're not tabletop. They're actually pretty large. But, this is only like 10 feet long, man. They need it like 100 feet. They just need it. It's got to be bigger, all right? Oh, well, yeah, so yeah, let's show you what's going on here. Yeah, there we go. So, yep, inject the gas into it, use the magnets to create a plasma and electrify it, energy, and accelerate it and shrink it down so it collides from this one over here, and then you have compression, which makes fusion, theoretically, and then they siphon out the electricity from this thing. But I think they're using the same capacitors they're using to charge it, which doesn't make a whole lot of sense, I guess, if you're really trying to siphon out a lot of energy. Maybe right now they're in testing an R&D phase, so it's not a big deal, but it's really something, man. I'd like to see more about that if they take it serious. But the approach that I believe is most tangible, most within reach right now, is cold fusion, right? And cold fusion is a dirty name in science. It has been for a long time. I think it's like 89. You got these two guys, right? Like Fleischmann and Pons, right? They're like in their 60s or 70s. They're older guys, but they were known as like the electrical chemical specialists, okay? And so they were working on, different ways of electrolysis, okay? And one of the apparatuses they used was This is their paper they initially put out in 1989, man. It's the first page. Strange behavior of electro-generated hydrogen dissolved in palladium has been studied for well over 100 years. And latterly, these studies have been extended to deuterium and tritium. For discharge of deuterium, like alkaline solutions in heavy water, we have to consider this reaction. So they say that there's been strange behaviors going on with electrolysis when you use palladium that's been studied going back 100 years, okay? And so that's why they were doing this. They were exploring this, looking for weird things, and they believe they found one. What they believe they found is the overall path. This is two steps. Dissolved. That's deuterium, whatever. Like hydrogen, it's got like two things, two neutrons instead of one, right? Is normally determined by the relative rates established negative OR potentials on the alkaline interface of palladium membrane electrodes where hydrogen dissolves, and going interface determined by the balance of all these steps demonstrated clinical process raised by blah 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 achieved. Okay, so this is the first page. They got like 10, I think, if I'm not mistaken. Yeah. So they put forward this paper, right, 1989. They're saying, listen, we did this experiment. And what we found was that we were getting more heat, excessive heat, than we were expecting, and we believe we were measuring trace amounts of like tritium. And tritium would really only come from fusion, right? You really shouldn't have that popping up in a palladium electrolysis machine unless there's some sort of fusion going on. So what they're claiming is that they got two electrodes made of palladium, right? A positive and a negative. And they're doing electrolysis. And electrolysis is just a positive and a negative node, and electrolyte like water, electricity going through it, and then it separates the water through electrolysis, where you got like cations go to one side, anions go to the other, which one's like hydrogen, one's oxygen, if I believe, and you're separating into gaseous, liquefied water into gaseous hydrogen and oxygen is what electrolysis is, right? And so they're doing this with palladium, all they're really doing, and they believe they're getting too much heat out, like things are getting too hot, and they think they're measuring tritium, okay? So this is cold fusion, they believe. And so they put out a call, right? They get peer reviewed. And the whole world of science shits on them, okay? But there's some real interesting things that come out of this that we need to look at that made my head turn, all right? Now, they're doing electrolysis. In electrolysis, these things heat up and the water bubbles. It's all hot, it's boiling technically. There's a lot of heat involved in this process. So the claim that they're getting too much heat from their experiment as compared to a regular electrolysis is sus. It's not a good lightning rod to stick to, to get hits on, because you got this thing where you're expected to get heat, and your complaint is, well, I think I'm getting too much heat. Unless it's like flash exploding, melting heat, I don't think it's too much from electrolysis. You can get a lot. All right. So they get together, right? The whole scientific community gets together and shits on these guys, right? And some part of that, a large part of it, was the Navy for some reason. The Navy got with all their laboratories and tried to replicate this for some reason, very uncharacteristic of Navy researchers. And they immediately come back and said, we think it's bullshit. We don't think there's anything here. Largely failed to replicate consistent verifiable results, leading to widespread skepticism, labeling as a fringe science. Though some continued research persisted, especially at Naval Air Warfare Center Weapons Division in China Lake, where initial excitement was due to improducibility. Some Navy researchers, like whatever, reported detecting excessive heat using special prepared palladium from Jonathan Matthey, but these results faced challenges and didn't become mainstream, solidifying cold fusion's controversial status. So, just know that the Navy used the DOJ, actually, the DOJ with the Navy, researched this for some odd reason as soon as it came out. And then, even though they say they were largely able to consistently replicate it, but they said they were able to get results that were very unusual, that did almost collaborate what Fleshman and Pons got, right? That's kind of odd to debunk something, but yet to also claim, but we did get some of the same results that they got, though, and we don't know what's up with that, but we're debunking this. It's just weird, okay? It's just the whole thing is fucking weird. And then it gets even weirder when this is like in the early 90s, right? When they do this. I remember this. I remember them debunking this shit and shitting on this guy ruthlessly, you know? And it was like, okay, wow, you know, they destroyed these guys' career. They were, you know, regarded as like the most well-known electrolysis, you know, scientists on the planet, and then overnight they're crackpot, you know, scientists. Don't listen to them, they're crazy, you know? And so, you know, these guys got their career destroyed because of this. And because of the Navy shitting on them like this, even though they claimed they got some of the results they got. And then what really got me was both these guys die, right? Because they're old. They're like in their late 60s. And so time goes on, 10, 15 years, and now in their 80s and they die. And they're gone. And they can't patent it anymore, and the technology can't be patented anymore because they're dead, and blah, blah, blah. And so now, like literally just a couple months after these guys die off, the Navy picks up their research again, right? 2009. And this time, Salt Lake announced series of experimental results confirms controversial cold fusion claims. Chief among the results, evidence produced by U.S. Navy researchers of high-energy neutrons is now a standard cold fusion experimental setup. Electrodes connected to a power source immersed in a solution containing both palladium and heavy water. If confirmed, the results would add the suggested the ideal reactions from a nuclear fire that lights up the sun. So this just got really fucking weird, alright? It was already weird that the Department of Justice tapped the Navy assets to discredit these guys, even though they claimed they were able to get some of the results they got. And then, suspiciously, they wait out these guys to die because they're old, and then 15 years later, they pick it up. And now, they're coming out, and they're not collaborating it, saying that it's legit, but now they're coming out saying that it's so legit, they've got such promising results that they dumped like an extra $20 or $40 million into the project, and that was the last I ever heard of it. And I never heard anything else of it since then. Fucking weird. If you think about it. It just doesn't add up. Except as evidence that these guys really did create cold fusion of some sort. But it wasn't good enough. Alright? And I mean, if they were able to start getting results from this experiment, I mean, there's so many things they could have done here. Like I say, they could have made the water like all heavy water, perfect, you know, ingredients, so they didn't have to have this preliminary reaction taking place. They could have doped prepped the palladium with extra holes blown apart by, you know, particle accelerators with just enough room from holes blasted by neutrons shot through those bad boys at high velocities that, you know, it's just enough that a deuterium can get in there and get packed in there. They could have put this whole apparatus under extreme pressure that would have really pressed everything in there even harder and gotten even better results. So many things they could have done to really test this out, but we're not done. If they really were getting the results they claimed they were getting, to push it in that direction to get more of those results. And I think that's what the Navy realized, but who knows what the Navy found? I don't. It just seems weird. The whole thing is just super freaking weird. All right. So, is this cold fusion legit? I don't know. I honestly don't know. But I do know this. The fact that the Navy took an immediate interest in it and was able to collaborate it, but yet debunked it, but then immediately, just months after these guys died off, resumed that experiment and then dumped millions of dollars into it, coming out saying, oh, we've got some really good results we're liking now. That makes me think that it really is legit. It just isn't very effective or efficient. But we can work on that. Like I said, there's methods you can do to make it infinitely, a lot more efficient and effective at getting fusion out of this apparatus if it really does work. Which it seems to me like it does work. It's just horribly inefficient and unreliable because they don't understand exactly why it's working. So they can't capitalize on this or that. All right. But that's not even what I want to talk to you guys about today. All right. All these things, like I said, the Helion approach to fusion, I think has potential. It could work. This cold fusion, I think, is possible. I don't know if it would ever be able to be used to generate large-scale energy, but it's possible. It's definitely possible. I don't want to say plausible, but it does seem possible based upon the Navy's reaction to it. It's just so fucking weird, all right? But all the other approaches, I think, are just false stones. They're not going to work out. But there is one. There is one form of fusion that is actually cold fusion, believe it or not, that not only does work, they were awarded like a Nobel Peace Prize for it working. Like, it works, okay? But there's a catch, as always. There's always a catch. Everything has pros and cons. So you want to maximize the pros and minimize the cons to make it work for you. Okay, that's the deal. That's what engineers try to do. But this approach that works is called muon fusion, or it's also known as the cold fusion that actually works. Like, no shit. If you Google that, you will get this. Alright, I know some of you are probably Googling it right now because you don't trust me. Shame on you. You should trust me. Alright. So, of course, here's one of my favorite, physics sleuths, YouTubers, Sabine Hassenfelder. I love her dearly, even though she hates me.
There's a type of cold fusion that actually works and has been experimentally verified for decades. It's called muon catalyzed fusion, and yes, there are actually people working on it. Last month, researchers demonstrated...
I did not know there were people working. I actually missed this video of her. I didn't see it until just this morning. But I found out about this just like 10 years ago. Not even, man. Yeah, about 10 years ago, yeah. So, I mean, there's a lot of people that are deep into the science world that have no clue this exists. And this is 100% real, legit cold fusion that works. Like, you would expect it out of a movie. It's insane. But there's a catch. We'll get into that.
A new way to produce muons using lasers, potentially solving one of the biggest practical challenges. And a startup called Accelerant Fusion is raising...
And what she's talking about is this also perked up my ears, right? So muons, muons have been incredibly useful for all sorts of things, right? Like they've been using it to scan things since like 2009. This technology is right, but they say to make it viable, like for everything. Like right now, they use muon scanning to scan the Great Pyramids to find like a chamber in there they didn't know existed. It's real, it works, but it takes like months because you're going by muons created in the atmosphere from solar events, and it takes time, and those don't happen very often. So they're saying if someone could create a portable muon generator, they could really change the world in a lot of ways. One specifically being just for us, we could now scan any vehicle in real time, without the use of X-rays in a much safer way and find out what's inside of it. All right. Also, they have created a muon generator for this. Now, I don't know about this one because this one is kind of old and it didn't make a whole lot of hubbub, and they don't do a very good job of explaining it. I'm still trying it. It's called EcoMug. But it does. They claim they're creating cosmic muons somehow with this process, and then those muons are being used to whatever. I don't know. The more I read about this, the more confused I get. They do a horrible job explaining what the hell it is and how it works. But yeah. Here's another one. Charge asymmetry of muon generated by muon generator from ultra-dense hydrogen. Okay. Laser-induced nuclear reactions in ultra-dense hydrogen. Now, this is 2019. Okay. So they've been making muons like that since 2019. And one of the ways you suppose you can make muons is you take like a magnetron that makes microwaves, and you hit that on like, I don't know, some conductive metal like copper, and then that will create a lot of pions. It'll rip pions off of the conductor like copper, and those pions will immediately decay into muons. So there are various ways that we have to make muons now, but what she's talking about and what's the most radical is this compact laser plasma accelerator. All right, and it can generate muons on demand for imaging, right, and for anything really. And that's what she's talking about. They're using lasers to generate these muons from a very small device, 30 centimeters. Like that's like tabletop. You can hold it in your hand. It's like a wand. You can just shoot someone up with muons, so like a wand, like and you've been moonified. I mean, so we're at that level now, okay? And that's a huge accomplishment because, let Sabine tell you, she says it better than me.
Money to save the world with muon catalyzed fusion. Just how crazy is this? Let's have a look. The biggest problem with nuclear fusion is that atomic nuclei are all positively charged, so they repel each other. You need to overcome this electric repulsion first until the strong nuclear force sets in. If the nuclei have electrons around them, this shields the charge of the nucleus up to some distance. But the electron orbits are so far away from the nucleus that this shielding doesn't allow you to get the nuclei close enough. Enter muons. Muons are elementary particles similar to electrons but about 200 times heavier. And because muons are so much heavier, their energy orbitals around atomic nuclei are much smaller.
Now, heavier is a funny word, because if you know me and my channel, you know that I am the only human being to ever live that knows what gravity is, has the math that perfectly calculates it with every observation ever. Yeah, get fucked, Einstein. And I understand what all matter is, including muons and tau muons and, freaking electrons, everything, antimatter, everything, all right? It's not that the muon is heavier, it's that the muon has more of the electric charge inside of it, which is affected by gravity. So that's kind of the deal. I just want to
This means if you replace the electron around a hydrogen atom with a muon, you can bring the nuclide closer together without...
And muons are bigger, though. They are bigger than electrons because they have much more electron density there. They're like a giant electron. But, and so basically you swap out the electron with muons that you want to have this fusion reaction, and now you don't need hardly any pressure heat. It just happens because the muon is so advantageous, the way that the structure of the hydrogen is set up, that it is very conducive for fusion to happen.
The electric repulsion getting in the way, and that much increases the fusion probability even at room temperature. The muon acts at
Room temperature, baby. Cold fusion. Keep in mind, this won a Nobel Peace Prize. Like, this was discovered back in like 1953. Okay, this is ancient known about knowledge. This is not new. This is ancient by science standards. But nobody knows about it. Nobody.
as a catalyst. Hence, it's called muon-catalyzed fusion. This was theoretically predicted already in the 1940s and first experimentally confirmed in the 1950s. So not like this is a new idea. But if this works, why aren't we powering the world with muon-catalyzed fusion already? As you probably guessed, there are a few problems. The first problem is that muons are unstable. They can only catalyze so many fusions until they decay. This wouldn't be such a big issue if it wasn't for the second problem, which is that in about 1% of fusion reactions between deuterium and tritium, the muon gets stuck to the helium nucleus, and then it can't catalyze any more fusions. This means that the number of available muons decreases. Typically, a muon only manages to catalyze about 100 fusion reactions. The observed record was 150, and that dates back to the 1980s, when people still had time for this kind of thing. That the muons get stuck also wouldn't be such a big issue if it wasn't for the third problem. Muon production is currently done with particle accelerators, and those aren't known for being energy efficient. So you need to put in vastly more energy than you get out of the fusion. But that was the status in the 1980s. And technology has come a long way since. Indeed, the startup Acceleron Fusion now wants to bring muon-catalyzed fusion to the market. In December, they raised $24 million to get it done with a proton accelerator. They shoot the protons into a target which creates pions that then decay into muons. To make their technology produce net energy, they need to make the proton acceleration as efficient as possible. And they also have a plan to avoid that the muons get stuck so quickly on the helium by putting the fuel under pressure, some 1,000 times atmospheric pressure. I
don't know if that will make it not get stuck, but I would assume that that would allow the fusion reaction to occur much more fluidly and often, which means it probably would have more reactions before it did get stuck, theoretically.
Somewhat skeptical that the proton accelerator will ever become energy efficient, but maybe the following can help. In March, researchers from the UK and Romania demonstrated a new way to produce muons. They do it with laser wake-field acceleration. Yes, that's the same technology that could shrink accelerators back down to something that doesn't take billions of dollars, international agreements, and a geological survey. Laser wake-field acceleration works by shooting a laser pulse into a gas, typically hydrogen. The laser deposits energy into the gas, which blasts electrons away, leaving behind a region of rapidly moving positive charge. This pulls in electrons from behind, so it accelerates them. This technology can produce electron energies in the range of some giga-electron volts over just a few centimeters.
Wow, that's really impressive, actually.
In comparison, the LHC has a pre-accelerator that speeds protons up to similar energy, but that's more than 100 meters in circumference.
Yeah.
Wakefield acceleration isn't yet good enough to actually build bigger particle colliders, but producing muons. Now that's a different thing. So in this new
That's a good
study,
thing.
the researchers used laser Wakefield acceleration to create GeV electrons, dump those into a lead target, and that produced about 10,000 muons per shot. Now, to be fair, they used a petawatt laser, which is still some 20 meters long or so. So if you want to call that a tabletop experiment, you'd need a very long table. And lasers aren't known for being energy efficient either. But that's still a remarkable achievement, which puts forward an entirely new avenue for muon production. Muon catalyzed fusion isn't going to power our homes anytime soon. But if they can get it to work, then particle physicists can brag that their accelerators were good for something after all. Did you know there's a free and easy way to
true.
learn more about the science behind all the videos?
Gotta love Sabine. I love her. So, that's the deal, okay? Cold fusion is absolutely real. We've known about it since 1945. But we have to swap out the electrons with muons, and muons have been extremely difficult to create or acquire in any way until recently, just this last year, where these guys claim to have made a method that can create them very easily, cheaply, with a very small device. So now muon catalyzed fusion is possible. And they're trying to work out all the minute details right now. The devil's always in the details, to make it work on a large scale and some sort of commercial setting. I think it definitely can work, 100%. I think muon catalyzed fusion can work on a large scale. I think the Helion approach to fusion has a possible chance of working if they want to scale it up and do all the angles. And the Pons Fishman cold fusion experiment, I think probably is legit, but it's just not efficient enough that we can really do much with it. So that's the deal. All the fusion projects that get the most money and the most hype, like the accelerators and whatnot, and the lasers, I think those are false stones. I don't think those are ever going to pay off, ever. I think at best they might just get a ball of plasma hot enough to boil your water pot, and that's about all they're going to get out of it. But the other three approaches that I've named, I do believe are valid. And the Helion approach, I think, could possibly work if they get crazy with it. And I think that the muon catalyzed fusion has proven 100% that it absolutely can, will, and does work if you just have enough muons to throw at it, which apparently now we can do. So, the state of fusion is looking like maybe in the next 20 years it might work. Or not, who knows, we'll see next time. Adios.
Like, subscribe, submit.